Welcome students. In this class we will learn how to solve this question. We've been given that if a negative b divided by 1 positive ab, positive b negative c divided by 1 positive bc, positive c negative a divided by 1 positive ca, if it is equal to 0, then show that either a is equal to b or b is equal to c or c is equal to a. So the understanding is, if this condition is equal to 0, then we have to show one of these three equations. In other words, either a should be equal to b, or b should be equal to c, or c should be equal to a. This should be shown. So having made that particular understanding clear, let us move on. Now, if you were to consider the quantities given, they are very similar. On observation, we can write the statement. We observe the close similarity to the formula tan of a plus b and tan of a minus b. Because since tan of a plus b is equal to tan a plus tan b divided by 1 negative tan a tan b, and tan of a minus b is equal to tan a negative tan b divided by 1 positive tan a tan b. So we know this formula. So this quantity that we have given, the equation we have given, has a similarity to tan of a minus b, right? Now what we are going to do is, if we choose alpha, beta, gamma to be element of negative pi over 2, pi over 2, then clearly we can substitute tan of alpha to be equal to a, tan of beta to be equal to b, and tan of gamma to be equal to c. Now how do I make this conclusion? Now if we were to draw the graph, there is an asymptote at pi over 2 and an asymptote at negative pi over 2. Now why is this possible? Because tan x is equal to sin x divided by cos x, and cos x it's 0 at pi over 2 and at negative pi over 2. Of course, you got other places where cos x becomes equal to 0, but that is not my consideration. My consideration is just between negative pi over 2 and positive pi over 2. Now, if we were to draw the graph of this tan x, then the graph would be something of this form. Now the meaning is, if I were to take, say, pi over 4, then tan pi over 4 is equal to 1. So meaning there is a point, say 1 over here, which corresponds, and that point which we are talking here is a unique point. In other words, tan pi over 4 will alone lead us to 1 in this case, between the interval negative pi over 2 to positive pi over 2. Because of this fact, if I were to take some a over here, then that a would correspond to a unique alpha, nothing else more and nothing else less. Because of this fact, because of this one-to-one nature, Of course, it is also onto. Because of that nature, I can make this substitution that tan alpha is equal to A, tan beta is equal to B, and tan gamma is equal to C. So having made that point clear, let us move on. So because of this, therefore, hence, the given problem is rewritten as in place of A I'm going to substitute tan of alpha, in place of B I'm going to substitute tan beta divided by 1 positive tan alpha, tan beta, positive tan beta, negative tan gamma divided by 1 positive tan beta, tan gamma, positive tan gamma, tan alpha, 1 positive tan gamma, tan alpha is equal to 0. I've got this. Now clearly I have started off saying that tan of A minus B is equal to tan A negative tan B divided by 1 positive tan A tan B. Now this is going to be tan of alpha negative beta positive tan of beta negative gamma positive tan of gamma negative alpha is equal to 0. So students, we have got this equation tan of alpha negative beta positive tan of beta negative gamma positive tan of gamma negative alpha is equal to 0. What I'm going to do is I'm just going to take alpha negative beta is equal to capital A and beta negative gamma is equal to capital B. I'm not going to touch gamma negative alpha. So because of this, what happens to the above system? It gets rewritten as tan of A plus tan of B plus tan of gamma negative alpha is equal to 0. Now we know that, I wish to bring your attention to this formula. We know that tan of A positive B is equal to tan A positive tan B divided by 1 negative tan A tan B. We know this. Now if I were to cross multiply the denominator, then I would have tan of A positive B multiplied with 1 negative tan A tan B is equal to tan of A positive tan of B. So clearly in place of tan A positive tan B, I would be substituting this quantity. So hence I can rewrite the above system to be as tan of A positive B multiplied with 1 negative tan A multiplied with tan B positive tan of gamma negative alpha is equal to 0. I can always write it like this. So now what I'm going to do is I have made this substitution. Let alpha negative beta is equal to A. So I'm going to replace that value here. So this is going to be rewritten as tan of, in place of A I'm going to substitute alpha negative beta. In place of B I'm going to substitute beta negative gamma and followed by 1 negative tan of, in place of A is going to be alpha negative beta. In place of B it's going to be beta negative gamma followed by positive tan of gamma negative alpha is equal to 0. Now clearly negative beta positive beta can be cancelled, giving me tan of alpha negative gamma multiplied with 1 negative tan of alpha negative beta multiplied with tan of beta negative gamma positive tan of gamma negative alpha is equal to 0. I can have this. So now what I'm going to do is I'm going to distribute this quantity. I'm going to remove the parenthesis, multiplying tan of alpha negative gamma into 1. So that's going to give me tan of alpha negative gamma, followed by negative tan of alpha negative gamma multiplied with tan of alpha negative beta multiplied with tan of beta negative gamma, followed by positive tan of gamma negative alpha is equal to 0. So I've got this. Now I just want you to consider this fact. Consider tan of gamma negative alpha. Now if I were to take a negative sign out, this is going to be negative of gamma. In fact, when I take a negative sign out, this will become negative gamma followed by positive alpha. Now, since tan is an odd function, so what is the meaning of odd function? F of negative x will be equal to negative f of x. So that is the meaning. So this means this quantity which you see here can be rewritten as, I'm going to rewrite it here. This can be rewritten as negative tan of negative gamma positive alpha. Of course, we can still further rewrite this as negative of alpha negative gamma. So this is always possible. So I'm going to take this information and I'm going to use it over here. So this is going to be tan of alpha negative gamma negative tan of alpha negative gamma times tan of alpha negative beta times tan of beta negative gamma negative tan of alpha negative gamma is equal to 0. Now positive tan of alpha negative gamma, negative tan of alpha negative gamma can be cancelled, giving me negative tan of alpha negative gamma multiplied with tan of alpha negative beta multiplied with tan of beta negative gamma is equal to 0. Now for this to be true, one of these quantities, tan of one of these, that is tan of alpha negative gamma should be equal to 0, or tan of alpha negative beta is equal to 0, or tan of beta negative gamma is equal to 0. So this should be the case. Now what we can do is we can assume from this fact, what we are going to do is let say alpha negative beta or alpha negative gamma or beta negative gamma to be equal. You can take one of these to be equal to 0. So what I'm going to do is I'm going to take let tan of alpha negative beta to be equal to 0. Now this is possible only if alpha negative beta is equal to 0. Now alpha negative beta is equal to 0. Why do I state it like this? For the fact alpha comma beta are contained in negative pi over 2 and positive pi over 2. So this means alpha negative beta would be between pi and negative pi. And for this range, tan of alpha negative beta can only be 0 if alpha negative beta is equal to 0. I hope you're following this important fact. And this would mean alpha is equal to beta. So this further means we know that in the beginning when we started we observed that tan of, I'm writing it down here, tan of alpha is equal to A. We started off with this concept. Tan of beta is equal to B. Okay, I've shown you why I've taken it that tan of alpha is equal to A and tan of beta is equal to B. Now, because of this fact, this means in place of alpha, we're going to have tan inverse of A is equal to tan inverse of B. Now, I can cancel tan inverse on both sides, because since tan inverse is 1 to 1 and onto, I can remove, we can remove tan inverse both sides. So this means A is equal to B, which is the required proof. So this completes the solution to this question. Thank you, students.